Alright guys, welcome back. So we're going to be solving another question from the engineering mechanics textbook and the dynamics part of that textbook. So we have a ball that is thrown vertically upward with an initial speed of 80 foot per second from the base A. So the ball is thrown up vertically from A, and the ball is gonna land at point B. So the question is asking us to determine the distance which the ball clears at the top of the cliff. So obviously the ball is gonna go up and it's gonna stop at some point in here. We can call this point C, and it's gonna come back to the cliff. And we also need to find the time t after the release for the ball to land at point B. So basically this travel time from A going to C and landing on B. And we need to calculate the impact velocity VB, which is basically the velocity at point B. We can neglect the air resistance and a small horizontal motion of the ball. So we're going to go with our formula. Let's just figure out the travel time. So basically the t that we are looking for is the TAC plus TCB. And what we know here, we have the VA, we have VC. So basically VC squared minus VA squared is going to be negative 2G times the height that we have, that we are traveling. So we can show that location with S. So SC minus SA. And we're going to put our origin for y in here. So we're going to consider this as 0. So C would be basically 50 plus H. So VC, first of all, we know it's 0 because it's going to stop at the apex. So at point C, there is no velocity. 0 minus 60 squared negative 2 times g, which is the acceleration of gravity. But based on the units that we have in this question, our g is 32.2 foot per square second. It's not 9.81 because that's based on the SI units. So 32.2, and our distance is basically 50 plus h. So 50 plus h, and this should give us the distance or the h that the question is asking in the first part. So negatives will be cancelled out from each side, and let's just calculate this ratio. Oh, I just made a mistake. Our velocity is actually 80, it's not 60. I don't know why I put 60. So this is 80 here, and here we're gonna have 80. So it's gonna be actually 90. So this is gonna give us 99.4. I'm just gonna round it up. So our H here would be 99 minus 50. So it's gonna be 49.4. So that's going to be our H. We found the first part of the question, and the question is asking us to find the time that we need. All right, so if we're going to move from A to B, we should be able to find the time with one of our formulas. So we have SB is equal to SA plus the initial weight, which is our point A, T negative 1/2 of G times T squared. And we're going to call our SB 50, and this will be 0. And the T that we're going to get in here is the time that it gets us to this height, the 50 feet height. And we have 2 time points that we're going to pass this height. So once this is going up, it's going to get to this height first, and it's going to go up and come back. And that's going to be our second time point. So if we have a quadratic equation, so we're expecting to have to get 2 different t's in here. So let's just rearrange this equation a little bit. So 50, we can just bring 50 on the other side. So 0 is equal to negative 50 plus the initial velocity was 80 times t negative 32 divided by 2, which is going to be 16.1 t squared. So we're going to have the quadratic formula negative b negative 80 plus or minus square root of b squared, so 80 squared minus 4 times negative 16.1 negative 50 over 2a, or so over 2a, so 2 times negative 16.1, this actually needs to be here. So let's just calculate this. 2 times negative 16.1. So our first t would be 0.733 seconds, and for the second one we just have to put a negative sign in here, and our second t would be 4.235 seconds. So as I mentioned, the first one would be where we get to here, and the second time point would be this. So now what we found the time, and the last thing is the velocity at b, and we can use our formula VB is equal to VA negative GT. So the velocity at B would be the velocity at A, which was 80, negative G is 32.2, and T here is the time of travel, so the time that it takes from going A to B, which we figure is the second time point, so 4.235, and let's just calculate this. 80 minus 32.2 times 4.235, and yeah, the velocity at this point is going to be negative 56.367 foot per second, and the negative sign shows that the direction of the velocity actually downward. And yeah, that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.